The next type of mean that we're going to discuss is what we call the weighted mean. So given some n number of data points, say in our example we have 5 data points, the mean that we had seen, otherwise known as a simple mean, which was denoted by x bar, is simply the sum of all the data points ranging from 1 to 5. So again, my data points are x1, x2, x3, x4, and x5. They can be anything from heights to lengths to weights, anything that is a quantitative variable. And we divide this by the number of data points. And we call this a simple mean. Sometimes, however, some of these particular data points have a higher weighing or higher influence on the mean than others. In the case of a simple mean, every data point have the same weights. But what if a particular value has a higher significance than the other 4 values? Okay, in that case, we have to introduce what we call a weighted mean. So weighted mean, mathematically, is given by, so we're still going to use x bar, but we're just going to put a subscript w to denote that it's a weighted mean. And this is going to be, we multiply each of our data point by a weight associated with each observation. So for observation x2, we're going to have a weight given by w2 all the way up to the 5th weight as such. And we're going to divide all of this by the sum of all the weights. So w1 plus w2 all the way up to w5. Putting this into summation notation, this is sum of all the values of the weights multiplied by their associated observation, and we sum this over all values of I, and we divide the sum by the sum of all the weights, or all the wi's. Okay. And we call this a weighted sum. Now let's take a look at an example to really clarify what exactly this captures. So in this particular example, I have scores of 2 types of cars. We'll call them car number 1 and car number 2. And each of these cars have been scored across 5 categories, namely safety, performance, reliability, interior, and design. Each of the score of each category ranges from 1 to 5. So car number 1 scored 4 on safety, while car number 2 scored 2 on safety. And we are given a factor weight for each of these categories. Okay. These factor weights indicates to us that safety, given a weight of 3, is something that is more important to a car buyer than something like the interior design and the exterior design of the car. Okay. The interior and the exterior design of the cars have a weighing of simply 1. Okay. So the higher the weight, the more important that particular observation or measurement is. Now if we were to do a simple mean for, say, car number 1, so simple mean for car number 1, x bar is going to be the sum of all the scores. In this case, I've done the totaling for you. It's 13, divided by the number of observations. We have 1, 2, 3, 4, 5 observation. And 13 divided by 5 yields 2.6. For car number 2, if we're to do the same thing and calculate the simple mean, it will be 16 divided by 5. And 16 divided by 5 is equal to 3.2. Okay. So just without weighing any of these factors or categories or these scores, okay, we see that car number 2 scored higher than car number 1. But they did not take into account how important each of these factors were. Okay. That there, a factor of 3 associated with safety, tells us that more weight should have been allocated to the scores of safety than the scores associated with interior design and exterior design. Okay, so why don't we calculate a weighted mean for car number 1? The weighted mean for car number 1, we'll put a W there to denote that it's a weighted mean, will be the weight factor associated with safety, and that's equal to 3, times the safety score, 4, plus the factor weight for performance, times the score for car number 1, plus 3 times 3. And continue on, 1 times 2 plus 1 times 2, all divided by the sum of all the weights, which is 3 plus 2 plus 3 plus 1 plus 1, which add up to 10. So we'll be dividing all of this by 10. If we calculate this weighted mean, we get an average of 2.9. Now let's do the same thing for car number 2. Okay, so let's make some room here. So for car number 2, X bar W will be the weight of 3, and it scored a 2 in that category. 2 times 4, 2 times 4, plus 3 times 2, plus 1 times 4, plus 1 times 4, all divided by 10. And the weighted mean for this car, for car number 2, ends up being 2.8. Okay. So what's interesting to note here is the fact that although car number 1 scored lower in terms of the simple mean, it has scored higher after we take into account the factor weights associated with each of the scoring categories. Okay. Obviously, when you purchase a car, safety should be the most important factor, okay, and the weighting associated with the safety category reflects that. Reliability should also be something that's a little bit more important than design, the interior design, and how the car looks from the outside. Okay. So overall, the weighted score of 2.9, okay, is slightly better than the weighted average of 2.8 of car number 2. One comment looking at the simple mean. The simple mean actually is a special case of the weighted mean where the weights assigned to each of the data points are basically equal to one another. So if all the weights given to safety, performance, reliability, interior, and design were equal to 1, and we were to apply this formula here, okay, 1 times x1 plus 1 times x2 plus all the way up to 1 times x5, all divided by the sum of all the w's, which is 5, then you're going to get the simple mean. Okay, as such. And I invite you to try that on your own, and you'll see that it's going to evaluate into 2.6 and 3.2 respectively for car number 1 and number 2. So there you have it, an example of weighted mean and why they are useful.